I'll just wait for my presentation a little bit. I'll say it's really lovely to be here. I've never been to a BIM meeting before, so it's a pleasure to be here. And as you may know, this is approaching end of fiscal year for the federal government, so it is really much nicer to be here with you than having my nose in my accounting spreadsheet. So thank you very much for that opportunity. So tonight I'm going to talk a little bit about the geospatial world. I think most of you kind of know what the geospatial world is from a Natural Resources Canada perspective, and in particular from the perspective of the Canada Centre for Mapping and Earth Observation. So I'm just going to assume that this works. Great. So I'm going to provide a little bit of a sort of a government perspective, a federal government perspective on the federal geospatial ecosystem, as we like to say. So some of the trends and some of the interesting things that are happening in the geospatial world more globally. And then talk about the role of the Canada Centre for Mapping and Earth Observation within that ecosystem. And then maybe just touch on a few of the more innovative things that we're doing at NRCan in the geospatial world. So what is a geospatial ecosystem? So this graphic, I came upon this several months ago, and I really like the way it portrays this ecosystem. So this is from a report by the Geospatial Media Communications folks in 2017 called the Global Geospatial Outlook. And so if anybody out there are GIS nerds, I really welcome you to read that particular report. It was really interesting. But what it kind of pointed to is that what once was in the geomatics world a very kind of quasi-science engineering field of study is really now geospatial information is riding on many other applications and produces a lot more knowledge than it used to solve human complicated issues. So who here has ever heard of Roger Tomlinson? So GIS nerd, I guess. So the founder of GIS, Canadian, from the 1960s, started to try to automate the process of using map information in a layered format rather than use physical, back in the day, and I did this in college, if you can imagine, overlaying transparencies to look at patterns in the geospatial world manually. So Dr. Roger Tomlinson kind of invented GIS, essentially. And so back in the day, he actually predicted that this would become mainstream, and you know, was quoted to say that geographic information data storage can actually be limitless because we can produce a limitless number of storage tapes. So just to date this ourselves a little bit, storage tapes. We've come a long way since then. So geospatial information technology are really have moved away from being a niche understanding and a niche expertise and really have become mainstreamed and in part of mass market technologies. So we expect this trend to continue. So I'm going to explain this graph a little bit. So on the left-hand side, we see the traditional practices of geospatial information management kind of at the data generation point. So in blue, as we move towards the right, we see organizations that are facilitating access and use. So I would say NRCan is kind of in the yellow and blue area. In green, we have technology that's using that data and processing it. And in orange, we have organizations that are using that processed data to add value and to develop citizen-centered applications. And along the bottom, we have those technologies that are really driving the use of the data. So in this context, I'm going to share some of the thoughts on some of the trends in geospatial data management. So AI and big data, everybody loves to talk about that these days, but there's really nothing new. So we are inundated, that's the trend. We are inundated with language around AI and big data, machine and deep learning. And these terms are generated by the fact that we are generating massive amounts of data. We are increasing at the same time our computational capacity. So think cloud, think high performance computing centers. And our technology around these is no longer robotic, it's more automated. So what's the opportunity here? The opportunity is there's a lot of remaining untapped value in this data. As expressed in the previous slide, it's across the ecosystem. So being able to synthesize and analyze all of this data more efficiently becomes actually an opportunity. But the challenge is we haven't really gotten there. We haven't maximized our ability to solve some of these complex problems in the world by leveraging these large and vast amounts of data. So obtaining value lies in our ability to take that data and rapidly convert it into something usable. So we need systems like AI and big data systems to more broadly, we need those to be more broadly available so that we can consider the geographic relationship between things. A lot of the data that we're generating actually has a location element associated with it. And so when we think of, for example, any organization that is using artificial intelligence to process large volumes of, say, satellite imagery, from a variety of sources and sensors, we need to be able to do that fairly quickly, and we need the computational power available for us to do that. So another trend that we in government pay attention to is a global desire to have a better integration of geospatial and statistical information. So beyond the classic economics and statistical study is really the understanding of the spatial relationship between things. And in 2015, the United Nations Sustainable Development Agenda actually mentioned that, pointed to the fact that geospatial data and Earth observation, reliable sources of that information, are really essential to be able to monitor our progress towards sustainable development. So the UN Sustainable Development Goals are an example of driving that need to know the location of things and integrate the statistical information alongside it. And I'll give you an example. Goal number 1, let's end poverty in all its forms everywhere. Okay, so that's a lofty goal that we have set for ourselves. But if you can imagine, how do we fix, if we even just look at Canada, how do we fix problems if we don't really have a good understanding of where they are? How do we sift through all of the satellite imagery and the air photography and the information that we have and bring in the socioeconomic information such as incomes and employment rates and community well-being indices? And how do we merge all of that information to get a good picture of what poverty actually is in Canada and how we're progressing towards this goal? So there's an opportunity to make sure that we manage our relevant geospatial information appropriately so that policymakers have layers of information available to them so that they're better able to make decisions around these kinds of policy objectives. But the challenge is they need access to that information from a variety of sources, ideally in a consolidated location. And that, in order for that to happen, the data has to adhere to a certain standard of interoperability. So the shifting legal and policy frameworks, governments love to think about these, but they're real. So funding is something that governments think about a lot, obviously. We want to expend taxpayers' money as best possible, but here's what's happening in the geospatial world, well, in the data world in general. Content is not free, but people are expecting it to be free, and the demand for free content is increasing. So Canada, like many other countries, has committed to making most of its geospatial data free. The FGP, or the Federal Geospatial Platform, that I'll touch on a little bit more later, is an example of that. You may be familiar with the Open Government Portal as well, all of it available for free to Canadians or to the world. So the government needs to think about its business models and how it can invest in ensuring it has high-quality geospatial data available, but at the same time meeting that expectation that it's available for free. Another trend we're looking at from a legal and policy framework perspective is privacy. How many people here subscribe to social media? Probably like all of you. Those who don't, nevertheless, many of the devices we have in our purses, in our wallets, in our cars, in our homes, are either emitting or collecting geospatial information. So while it may give governments the ability to use that information for security purposes and to be able to track its citizens' safety, it also can become in the hands of more malevolent purposes. So standards is another issue, and I'll talk a little bit more about standards towards the end of my presentation, but the geospatial data community is pretty advanced in terms of standards. For decades, it has been working globally to ensure interoperability and standard approaches to sharing data. So as technology evolves, more global data sharing is going to be required. So that's going to force countries like Canada and Europe and most of North America, who are fairly advanced in their standards approach to sharing geospatial data, to promote that adoption of those standards more globally so that data can continue to be interoperable. And then there's the liability issue. A lot of the geospatial data that is being made available to Canadians for free comes with risks of use. So any open government faces this same issue, that there needs to be clarity around the appropriateness, the quality, the accuracy, the reliability of that information. And there may be required another look at our legislative framework to ensure that both the people, the organizations providing data, and those that are using this open and free data, that those liabilities are covered. So, location is mainstream. As I've said, more free, more open data from more sources. Cloud computing is helping us avoid major infrastructure investments. Geospatial products and technologies are available to business today. And the industry is no longer limited to a few specialized companies. Every industry can leverage geospatial information with new ventures emerging that are built on big geospatial data. So what kind of opportunities does this allow? Well, it allows companies to create value so they can use geospatial data that is widely available, often for free, to create new value streams for themselves, such as business information maps, for example. Real-time business information can be acquired through geospatial information so they can better understand their own business processes and become more efficient. So I'm thinking where product deliveries are, where suppliers are located at any particular point in time. So the challenge is to move to open and free data and ensure that the industry is able to take advantage of that and have revenue streams, and ensuring that the technology is there to enable those industries to capitalize on that available data. So the changing role of government. So national mapping agencies are usually, when we think about the government's mapping organizations, we think surveying, we think geodesy, we think cartography, and those are often linked to the responsibility for measuring land and the production of products around our Canadian landscape. So this is still important work. These foundational layers provide the sound basis for decision-making around the management of the Canadian landscape. So there's some opportunities. We need to continue to carve out space for investment in these foundational layers to support government priorities and ensure that there's a solid, accurate, authoritative base upon which government programs can be delivered and monitored. Citizens need this information about their own country's landscape, and we need to know, Canada needs to understand how its built infrastructure and border protection, that the foundational layer is available to support those as well. But there's some challenges in that. It's difficult to put a monetary value on geospatial data, and in particular, when it is being propagated and freely distributed. So this is an issue I've heard many times in the open government forums that I participate in, that what's the value to Canadians? What's the value to the world in making this data open and available? We don't really have a good handle on that because it's difficult to assess that after the fact. It's free, it's available. There may be all kinds of innovations and profits being made, but we'll never really know. So we just have to base that on some assumptions. And also, the demand for accurate and current and real geospatial data from authoritative sources can be labor intensive and does require continual investment. And so we want to make sure that initiatives such as OpenStreetMaps and Google Maps that have roads and they have buildings and they have all these interesting, apparently complete looking layers, may not be from a federal government perspective what we would consider authoritative. They may, we don't really see that as duplication. We see a government investment in those foundational pieces of geospatial information as kind of critical for government decision making and for policy making. And just finally on the changing role of government, education and training in the geospatial world, it used to be that we would recruit from Algonquin. Algonquin College has a fabulous technology program, but nowadays we're expecting a broader spectrum of our new recruits in the areas of policy, in finance, in computer science, to have basic skills in geospatial analysis. So it's no longer a specific skill set from a specific program. We're looking for that to be mainstreamed. And so having those skills built into our workforce continues to be a challenge. So the Canada Centre for Mapping and Earth Observation. So this is an organization, I last count 270-ish people, my colleagues. And so, oops, I'm going to change to this. There we go. So this diagram describes some of the areas of expertise that we have in the Canada Centre for Mapping and Earth Observation. It's a fairly small organization with a fairly large mandate. So on the left-hand side, we see the Canada Centre for Remote Sensing. So when we say remote sensing, we mean the scanning of the Earth by satellite or aerial aircraft in order to obtain information about it. Simply put, that's what we say remote sensing is. So this center is basically our science arm. It undertakes scientific research to develop remote sensing products, applications, and these are essentially to meet the requirements of federal, provincial, and territorial governments. It does this through research partnerships, transferring the technology that they develop around remotely sensed information to private, academic, and non-governmental sector. It also is responsible for a small team of geomatics experts that are called the Emergency Geomatics Service, and these folks are deployed during Canadian emergencies such as flooding and fire to use remotely sensed information to provide situational awareness and analysis to government operations in the case of an emergency. And then the next box over, I guess it's orange, I don't know what it looks like on your screen. So this is the Canadian Geospatial Data Infrastructure. So this is essentially our standards division. So it strives to ensure interoperability of geospatial data through policies, standards, and frameworks. So it also has the dual role of managing some critical ground operations which receive and disseminate Earth observation data from Canadian satellites and airborne and space missions. So there are receiving stations in Inuvik, in Gatineau, and Prince Albert, and this division collaborates with the Canadian Space Agency and the Department of National Defence in these operations. So it also administers a grants and contributions program you may have heard of called GeoConnections, and GeoConnections is a national partnership that facilitates with the industry the access and use of geospatial information in Canada. It also has another function. It's a multi-purpose division. It is the secretariat function for what is called the Geographical Names Board of Canada. So this is a federal, provincial, territorial body that has been around for many, I don't know, for many years, and is the federal, and is the authority responsible for the standardized naming of geographical features in Canada. And I'll show you a quick example of that a little bit later. We have our GeoBase division. So the GeoBase division is the blue in the center. This division is responsible for developing, maintaining, coordinating key foundational geospatial layers for all of Canada in land, water, and infrastructure. So in particular, we're talking about toponymy, so place names, elevation, hydrography, infrastructure, energy, and transportation. So some of those foundational pieces upon which the thematic information can be layered. They also, they achieve this through multi-jurisdictional collaboration. So again, working with provinces and territories called the GeoBase Steering Committee. And they work together to stitch together the information available from provinces and territories and the federal government to create those national layers of information. It's also a center of expertise in innovation and experimentation in the use of geospatial data and technology. And then we have in yellow, we have, this is actually our corporate office, but what's interesting about our corporate office is it also houses the National Air Photo Library. So some of you may have been there on Booth Street. It still exists. So the National Air Photo Library is a service center where you can have access to over 6 million air photos of Canada dating back for over 100 years. The Canada Map, it also houses the Canada Map office, which is where you can get topographic maps. Remember those? They're available on, that information is available online as well, but we do house and still print topographic maps. We also certify private sector organizations to be certified map printers. So they take our data and information and print it and resell it to the public. And then finally, of course, most importantly, because that's my division, is the Federal Geospatial Platform. So the FGP, you can consider it as sort of the distribution arm of all of this, where Canadians and employees can access all of the products and information that are generated through these divisions, but also across other governments. I won't go into too much on that because I have more slides on the Federal Geospatial Platform coming up later. Oh, and there you go, right now, as a matter of fact. So back in the day, before the Federal Geospatial Platform existed, if somebody wanted to get information to do, let's say, some policy analysis, they needed to look at environmentally protected areas. They needed to understand where the railroads were. Perhaps they needed to know where the Indigenous communities were located. Maybe they needed to know what some of the legal frameworks were around a particular area. That involves no less than 4 federal departments. I don't know if you've ever tried to get information out of a federal department, but it ain't easy. It takes a long time. So this was identified in the geospatial community as a weak link that needed to be addressed. So back in 2014, for a number of years, the federal government has been trying to get itself organized in the geospatial world and has a committee called the Federal Committee on Geomatics and Earth Observation. So this is a very senior level committee. 21 departments participate, assistant deputy minister level. So 2 down from the minister, essentially, get together and talk about issues around geospatial data, information, and talk about things like sharing, ensuring coordinated approaches to investments in geospatial data, talk about issues such as space strategy, Earth observation strategies, a variety of topics. And they endorsed the idea of a 3-year project to bring together the federal government's geospatial information and make it available online in a single place. So that required no new money. So that's one of the first things that was appealing, obviously, to assistant deputy ministers is we didn't ask for Treasury Board for money. We said, we think there's enough capacity and enough goodwill across the government to make this happen voluntarily. So that's what happened. So it was established during a 3-year project. It ended in March 2017 with 10 federal departments financially supporting this initiative. So its key goal was to have a collaborative online space to ensuring that the government's authoritative data, so those data sets that departments deem are appropriate to be shared and published, available in a single location. And this was all based on a standards approach on policies and ensuring that we're using efficient and leading edge technology. So government and leading edge, yes, it is possible. So the platform was launched in, just as a very good graphic of it, it kind of looks like, this is essentially our data catalog. So it was launched in June 2016 with a fairly simple website that allows you to browse through a catalog interface to find now I think we've hit 1,000 data sets from 17 contributing departments. And And what it did, it also has a map interface, so you can choose which layers to look at and do analysis if that's what you choose. So there's a number of personas that we explored to see how we could make sure that this website was meeting a variety of needs. So we looked at managers. We wanted to make sure that they're able to find data quickly. An economist, what does an economist want? They wanted to be able to, a simple tool to do simple geospatial analysis around a particular economic issue. Same with policy analysts. We didn't want them to have to be experts in GIS to be able to use this tool. A data analyst should be able to download the data and be able to use it for their own purposes. We wanted to make sure that IT professionals could add another tool in their toolkit to be able to manage enterprise issues. We wanted to ensure that researchers were able to browse through some metadata and know what is appropriate for their particular use, and to be able to collaborate with other researchers. Geomatics professionals, while many geomatics professionals own much more sophisticated software than what our simple website provides, we wanted to make sure that they had access to data at their fingertips. And we wanted to enable all federal departments an easy way for them to self-publish their information and put it in our catalog, and then open it, if they choose, to the Open Government website. And so what this rather simple-looking website accomplished was a lot bigger than we thought. So what it did is it brought together those 10 departments towards an enterprise solution to solving a problem that the government had in sharing their geospatial data. And again, with reallocating existing resources without new money. It enabled open and shareable information to be visualized. If you look at the Open Government website or any Open Government website, often you're faced with tabular information that's kind of hard to see and it's hard to work with. What this did was enable a visualization tool so that it's much more easy to interact and understand the data. It supports a number of priorities, and I'll share those with you in the next slide. It's accessible, so not only is it accessible to the federal government, it's accessible to Canadians as well. Departments can choose which information is available only to the federal government, and there's an interface for that. And we use the Open Government site as our way to share all of the data that departments have deemed shareable with the public. And that's about 90% of what has been contributed thus far. And we engage continually with other departments, and we're engaging with provinces and territories as well to bring in that data, so to make sure that we're meeting the needs of our federal family and our provincial and territorial colleagues. So just to highlight quickly a few priorities that this has enabled. So enabling us to contribute to the Open Government movement. Cumulative effects assessment, so environmental impact assessment, ensuring that we are, that initiatives around impact assessment are leveraging geospatial data and technology to support those policy requirements. Marine spatial planning, so ensuring the Department of Fisheries and Oceans and Natural Resources Canada are sharing data and are using common standards to share that information. Flood mapping, this is a topic that we're all going to be faced with fairly quickly, I can imagine. And so we're looking at using Earth observation products and disseminating those in the platform to make sure that they're available to support situational awareness. And as I've mentioned, enhancing geospatial and statistical data integration, so improving Canadians' ability to look at socioeconomic information on a map and deepen their understanding of it. So ultimately, this is our Open Maps site. So this is something that we released on November 9th, I believe it was, and just in anticipation of Remembrance Day. So what you're seeing here is just a screen grab of a map. All the dots on the map represent locations in Canada that are named after war veterans or soldiers or places that are commemorative of one of our activities related to war. So we call it Canada's commemorative map. Our Minister of Natural Resources released it at or announced it at the War Museum on November 9th. And if you click on any one of those dots, you can get some basic information about that place name, who it was named after, and in many cases you can get a picture of that particular individual. So this particular application was a project of the Geographical Names Board of Canada, who houses a tremendous amount of interesting information about the place names in Canada. And this was one of the maps that we generated, and it is available on the Open Government website, and you can explore it if you're interested. So that's just an example. So now I'm going to quickly talk about just a couple more innovations that are going on at the Canada Centre for Mapping and Earth Observation. Some of my colleagues were kind enough to feed me a few projects to speak to you about. So the first one is LiDAR-derived building footprints. Now, we see building footprints all over the internet, so this doesn't look like anything new. But again, remember, the federal government is there to provide an authoritative, fit-for-purpose layer of information. And the objectives of this particular project were to develop that building layer from raw data in an automated fashion and create valuable from what was an existing asset, which was some LiDAR information that we had for a large portion of Canada. And to have the ability to refresh that on a regular basis and to ensure that we can use that information to support emergency preparedness or mitigation and response. So think earthquakes and floods. It's nothing new for the Canada Centre for Mapping and Earth Observation to use AI and big data. They've been doing this for many years. And as I mentioned, one of our responsibilities is these foundational data layers for Canada. But those have been traditionally done in much more manual fashion. So in the past 2 years, they've been exploring how can we automate the maintaining of these particular layers in a much more effective and efficient way so that they're as current as they can be. So the first result was the auto buildings layer. And so this is just a pilot, so it's only been experimented in a couple of locations in Canada, but it consists of a single topographic feature class that delineates the polygons for building footprints, automatically extracted from LiDAR data, and as well as high-resolution optical imagery and other sources. So this first pilot generated about a million buildings. And those buildings also available, this layer of information, oops, I went a little fast, available on the Open Government website. The other element is that using LiDAR information, the possibility of extracting three-dimensional information, so building height as well with a fair amount of accuracy, so enabling a full range of possibilities. One of those possibilities is looking at, the team has developed algorithms to be able to detect the surface and aspect ratio of houses. So what the experiment that's happening here is they're looking at what's the likelihood that if you put solar panels on that particular piece of roof, what would your energy potential savings be? And so this is entirely experimental, and no, this isn't a government program that we're rolling out, but it's certainly something that we're looking at in terms of an innovative tool to develop government policy around. If we have this capability, perhaps we have the ability to specifically target those houses in the red and email or send them something through the mail to say, you know, you could save a tremendous amount of energy if you put solar panels on your roof. This is how much the estimate is. Again, entirely experimental, but certainly something worth looking at from a government policy perspective. The other use case is flood simulation. So being able to have an authoritative building footprint and simulating flood events. Here's where the experimentation is more around the merging of geospatial and socioeconomic information, whereas we would not want to know in a flood situation who's in those buildings. Are there people at risk? Are there people that would need support in an evacuation situation? So being able to blend those pieces of information from multiple sources becomes an essential piece of study. Oops. I'm going to spend just a couple seconds on interoperability. None of this is possible without standards, and my colleagues in the standards area would be very happy to hear me say that. So geospatial standards ensure that the data that we generate and the data that we use, that it's formatted according to a consistent set of requirements. So tools that make use of geospatial data, such as GIS software and web mapping services, can implement these standards. And through these standards, geospatial data collected collected by different people and different industries becomes consistent, and this allows it to be shared widely. So standards allow interoperability, meaning that different software applications can be agnostic as long as the geospatial information is implemented to a certain standard. So in a way, plug and play. The user doesn't need to know what's happening in the background. They just need to know that the data is interoperable. And this is particularly of interest to the architecture, engineering, construction fields. This field of work, projects in this area consume a significant amount of geospatial data and possibly produce a significant amount as well. Multiple actors such as contractors and governments and the public can benefit from accessing and using this information. But how can we use it, how can we ensure it's used efficiently and effectively? And the answer is standards. Standards, so that everybody's speaking the same language, so that we don't have to think about it. It should just be able to work as it is. And so the role of government in all of this standards business is that we play a leadership role in bringing folks together to talk about standards, to adopt common standards, to ensure that those people who will be affected by adopting these standards have a voice at the table. We interact with multiple stakeholders, municipal governments, provincial governments, territorial governments, international academia, and we advocate for our own national interests in international fora around standards. And it helps communicate the value, we help communicate the value of standards by standing in front of groups like you and talking about them. So when, just to touch on, something top of mind, the idea of smart cities. So there's a tremendous amount of data required to support the smart city concept. Many individuals, groups, governments, industries will need to use this information. So open standards ensure that it can be used easily and effectively for many, many different applications. So as we increase the value of smart city data, this in turn will result in improvements in our smart city infrastructure. And finally, there's economic impact. So there's some studies that have been done, one in particular on the UK, investigating the impact of geospatial standards on street construction activities. So street construction involves the coordination amongst multiple agencies, so multiple levels of government, utility companies, the public. So knowing the location of the infrastructure is critical before any work starts, and standards help ensure that separate groups with different interests can communicate seamlessly in this fora, and supports work planning and execution. And I welcome you to look at that study if you're interested. And that's it for me.